Hi everyone, today we'll be looking at the May 2019 QR Mathematics 1 paper. Question 1, we've got the curve C defined by this expression here and we need to find the y dx. Before we actually proceed, we will have to write the y in a form that can be differentiated. So it's 1 over 8x cubed minus 24 over x to the half plus 1. So y is an 8th x cubed minus 24x to the minus a half plus 1. Now dy dx, we get the power down, so 3 over 8, and we deduct 1 from the power, x squared, minus 24 times a half x to the minus 3 over 2. The plus 1 goes away, so this simplifies to 3 over 8 x squared plus 12x to the minus 3 over 2. Now in part B, we are being given that we've got this point P 4 minus 3 lying on C, and we need to find the equation of the tangent to C at P, giving you our answer in the form y cos mx plus c. So I will actually start off by evaluating the y dx at x is 4. This will give me the gradient of the tangent. So I'm substituting x with 4. I plug everything on the calculator. I get an answer of 15 over 2. We know that the equation of a straight line passing through the point x1, y1 and having gradient of m is given by y minus y1 is mx minus x1. So y minus 3 is 15 over 2 x minus 4. I will expand the right hand side, it will give me 15 over 2x minus 30, leading to a final answer of y being 15 over 2x minus 33. Question 2, we need to show each stage of our working, and we need to start off by simplifying 1 over 4 minus 2 root 2. I need to rationalize the denominator, so in order to do that, I will multiply intelligently by the number 1. It's going to be 4 plus 2 root 2 over 4 plus 2 root 2. Essentially, it's a repetition of the original denominator with the sign change so that we mimic a difference of two square structure that will allow the square roots to go away. So in the numerator, I have 4 plus 2 root 2. And in the denominator, if we do the expansion, it's 4 times 4 is 16. 4 times 2 root 2 is 8 root 2 minus 8 root 2. And then 2 root 2 times 2 root 2 is 8, so minus 8. The 8 root 2 with the minus 8 root 2 goes away. And I'm left with 4 plus 2 root 2 over 8. Now I will express this as 4 over 8 plus 2 root 2 over 8, which simplifies to 1 over 2 plus 1 over 4 root 2. Now in B, it says hence or otherwise solve the equation given here. So let's start off with the given equation. We've got 4x is 2 root 2x plus 20 root 2. I will collect the x terms on the left hand side with an intention of factorizing out the x. So this is the form minus 2 root 2, and then solving for x gives me that x is 20 root 2 over 4 minus 2 root 2. Now we know that 1 over 4 minus 2 root 2 is simply the answer we obtained in part A of this question, which is a half plus a quarter root 2. So if I expand this, well, 20 times a half is 10, so it's gonna be 10 root 2, and then 20 times a quarter is 5, root 2 times root 2 is 2, so this is 10 root 2 plus 10. Question 3, we've got a plan of a garden. The 6 edges are straight lines. We've got the lengths in meters. Given that the perimeter is greater than 29, we need to show that x is greater than 1.5. Now, the perimeter is simply the sum of all of these, and instead of considering expressions for this side and this side, you simply need to observe that all of these length is 6x minus 2, which is exactly the same as the 2x minus 1 plus this part here. So if I just do 2 times this, I have the horizontal parts, and similarly for 5x, I'm gonna be doing 2 times 5x to find the vertical parts, and adding everything up should give me the perimeter. So 2 times the 5x plus the 6x minus 2, that's the expression for the perimeter, is greater than 29. I could expand into 10x minus 12x minus 4 is greater than 29, which leads to 22x greater than 33. So x is greater than 33 over 22, which of course simplifies to 1.5 as required. Given also that the area is less than 72 square meters, we need to form and solve a quadratic inequality in X. So I could actually consider a straight line here to split it into 2 rectangles. So it's easy to see that this should be 3x because I've got 2x and all of this is 5x. So it must be the case that this is 3x. And if I add the 2 areas here, I should be finding the total area. Now, the top part is 2x times 2x minus 1, and the bottom part is 3x brackets 6x minus 2. The sum of these should be giving me the area. So what we get is that 2x brackets 2x minus 1 plus 3x brackets 6x minus 2 is less than 72. I will expand to get 4x squared minus 2x plus 18x squared minus 6x is less than 72, which leads to 22x squared minus 8x minus 72 is less than 0. I will divide everything by 2 to make the numbers a bit more manageable. 11x squared minus 4x minus 36 is less than 0. And I need to solve this. This factorizes into 11x plus 18 brackets x minus 2 less than 0. It's a quadratic inequality. I will derive the critical values, which are the values that make the left-hand side 0. It's either 11x plus 18 equal to 0. So 11x is minus 18, which leads to x being minus 18 over 11. Or it's gonna be x minus 2 is 0, which means that x is 2. Now, I will draw my parabola. It's a smiley face because if I expand the original thing, it has a positive coefficient for x squared. This is the minus 18 over 11. This is the 2. It goes plus, minus, plus. We wanna be less than 0, so I wanna be here. So my answer to part B should be minus 18 over 11 less than x less than 2. And then C says, hence state the range of possible values of x. So I need to combine all the derived information up to this point. So part C, I will draw my number line here. This is x. We have found that x must be between minus 18 over 11 and 2. So this is the result of the quadratic inequality. And I will also illustrate the first inequality we derived. So we have found that x was greater than 1.5. So this is what we have here, the 1.5. And we are interested in the region where both inequalities are being satisfied, and it's obviously between 1.5 and 2. So 1.5 less than x less than 2. In question 4, we need to integrate this with respect to x, giving the answer in its simplest form. I will start by writing each term over the denominator of 2 root x. So I need to put in a form that allows integration to take place. So the 4 with the 2 leaves me with a 2. Root of x is x to the half. So x squared over x to the half is x to the 3 over 2 plus 1 over 2x to the minus a half dx. A common mistake is for people to get the 2 in the numerator as well. No, the 2 stays in the denominator. It's a half x to the minus a half. It's time for me to integrate, so I increase the power by 1 and divide by the new power. Similarly here, it's a half x to the half over a half. And don't forget the constant of integration. All of these leads to 4 over 5 x to the 5 over 2 plus x to the half plus c. In 5, we need to use algebra in the first part to find all real solutions of this cubic. I will start by factoring out x to give me x brackets 2x squared plus 3x minus 35 is equal to 0, which further factorizes into x brackets 2x minus 7, x plus 5. I need to find the solution, so either x is 0 or 2x minus 7 is 0 or x plus 5 is 0. So we've got 2x is 7 here, x is 7 over 2, x is negative 5. So 3 solutions in total, the 0, the 7 over 2, and the negative 5. And B, hence find all real solutions of this equation here. The hence means that this part follows on straight from the previous part. You need to find a connection between the two equations. It doesn't take long to realize that the x became y minus 5 all squared. So that's the connection between the second equation and the first. Now we have the solutions for x. So either y minus 5 all squared is 0 or y minus 5 all squared is 7 over 2 or y minus 5 all squared is negative 5. Now the first thing I notice is that in the last part here we have no solution. We can't have something squared giving you a negative answer. So I'm just gonna say reject, not valid. Now for the first part, y minus 5 all squared is 0, we just get y is 5, and y minus 5 is plus minus the square root of 7 over 2. Do not forget the plus minus here, so y is 5 plus minus the square root of 7 over 2. So a total of 3 solutions. In question 6, it's the line 4x plus c being a constant, meeting the curve x minus 3 at only one point. We need to find the value of c. First of all, if they meet, it means that I can set them equal to each other. So 4x plus c is equal to x brackets x minus 3. I will expand. 4x plus c is x squared minus 3x. And I'll be collecting everything on one side. 0 is x squared minus 7x minus c. Now, if they meet at only one point, this simply means that the discriminant of this quadratic must be 0. So b squared minus 4ac is 0. So 49 plus 4c is 0. 4c is negative 49, which means that c is minus 49 over 4. That's the value of c. And it says, hence, in part B, find the coordinates of the point of intersection. So now that we know that c is minus 49 over 4, I will simply go back to this equation here, which was the result of equating the line and the curve and replacing c with the value we just found. So this leads to this quadratic equation. So we've got that x squared minus 7x plus 49 over 4 is 0. I could multiply everything by 4 to get 4x squared minus 28x plus 49, which is a perfect square. It's 2x minus 7 all squared. So 2x minus 7 is 0, which leads to x being 7 over 2. We are not done. We need to find the y value as well. So I'm going to use that y is 4x plus c. Put this on the calculator. We get 7 over 4. And therefore the coordinates of that single point that they meet is 7 over 2, 7 over 4. In 7, we've got this shape ABCDA, and we need to start off by finding the area of the major sector here, this one here. Now we know that the area of a sector, provided that the angle is measured in radians, is given by a half r squared theta. Now, since we know that this here is 0.7 radians, we can safely conclude that this is 2 pi minus 0.7. That's the angle we're interested in, and therefore I'm just gonna say that we've got a half, the radius is 6, so 6 squared times 2 pi minus 0.7, which gives an answer of 100.5 squared centimeters. In B, given that angle ADO is obtuse, find its size. So ADO is the angle here. I'm just gonna call it theta. And we could use the sine rule. Now, sine of 0.7 over 5 is equal to sine of theta over 6. If I cross multiply, I get 6 sine of 0.7 over 5 is equal to sine of theta, and gives theta to be 0.88365. However, this is not the answer we were after, because we were told that the angle ADO is obtuse. The theta we found here corresponds to an acute angle. Well, we know that sine of theta and sine of pi minus theta, since we are in radians, is the same. This is the ambiguous case of the sine rule, and therefore I have to say that ADO is pi minus 0.88365, which to 3SF is 2.258, to 3 decimal places, sorry. Hence, find the perimeter, it says, of the shape. So I will start by finding the third missing angle here, because in order to find the perimeter, it's the length of the arc. I can find it straight away. It's the 5 centimeters part, the AD, and then the CD is just the radius minus the OD part. So I will start off by saying that this angle here, OAD, is simply pi minus the 0.7 and the answer we just found, the 2.258, which gives an answer of 0.18365. So I could use the sine rule to find OD. So sine of 0.7 over 5 is sine of 0.18365 ... over OD. It's a good idea to maintain full accuracy throughout. OD will simply be 5 times the sine of 0.18365 over the sine of 0.7, which gives an answer of 1.417396. And therefore the perimeter will simply be the arc the AD and the OD. Now we know that the length of the arc is given by r theta. My r is 6, my theta is 2 pi minus 0.7. The AD is simply 5, and the OD we just found to be 1.417396. Sorry, it's 6 minus that, because the OD, this part here is what we have found. We want CD. So I should have written here CD. And if I add this up, I get 43.1 centimeters. In question 8, we've got this curve and we're being given the derivative. We know that it passes through the point 4, 1, and we need to find the equation of the normal. Now to find the equation of the normal, I will start by substituting 4 into f dash of x in order to get the gradient of the tangent. This gives an answer of 35/6. We know that the gradient of the normal can be found by flipping this and changing the sign. So it's going to be minus 6/35 because the normal is perpendicular to the tangent. And then we've got y minus y1 is mx minus x1. So I'll be substituting the point y minus 1 is minus 6/35 x minus 4. I will cross multiply to get 35y minus 35 is negative 6x plus 24, which leads to 35y plus 6x minus 59 is 0. That's the equation of the normal. And then part B, for 5 marks, we need to find f of x. Well, I will start by integrating to get an expression for f of x. So it's the integral of 4 root x minus 2 minus 8/3x squared dx. I need to put it in a form that allows integration to be carried out easily. So I will write this as 8/3x to the minus 2 dx. And now I increase the power by 1, divide by the new power. So minus 2x minus 8/3 x to the minus 1/-1 plus c, the constant of integration. This simplifies to 8/3 x to the 3/2 minus 2x plus 8/3 x to the minus 1 plus c. In addition, we know that f of 4 is 1 because we pass to the point 4, 1. So we have that 1 is 8/3 times 4 to the 3/2 minus 2 times 4 plus 8/3 times 4 to the minus 1 plus c. If you put everything on the calculator, you get that 1 is 14 plus c, which means that c is minus 13. And the only thing missing is to write out that f of x is 8/3 x to the 3/2 minus 2x plus 8/3 x to the minus 1 minus 13. Question 9. We start off by being given the graph of sine theta. It's in degrees, the maximum at 91, the minimum at 270, minus 1. And we need to state the coordinates of the minimum point on y is 4 sine theta. Now, if we've got y is 4 sine theta, this is a transformation corresponding to a stretch along the vertical scale factor of 4. This means that all the y values get multiplied by 4. So we multiply y by 4. So if in the original graph of sine theta the minimum was at 270, minus 1, if I multiply the y's by 4, I'll go to 270, minus 4. We're then being told that we've got diagram 1 on which we need to sketch and label y is 1 plus sine theta and y is tan theta. So two graphs to be drawn. So this is the sine of theta. 1 plus sine theta, it's a translation 1 unit up. So it's gonna be something like this. So all the y values get added 1. So this is 1 plus sine theta. And for tan theta, we know that the characteristic of the tan wave is that we've got asymptotes at 90 and then every 180 degrees. Asymptotes are lines through which we do not pass and we just approach. So it should look something like this, cutting at 0, 180 and 360. So this is tan theta. And then part C, hence find the number of solutions for tan theta is 1 plus sine theta in the region of 0 to 2160. I will actually start by identifying the points of intersection between the red and the blue curve. So we've got one point here and another point here. Now the range of 0 to 2160 is a multiple of 360. It's actually 6 times 360. And we see that if in a span of 360 degrees we have 2 points of intersection, then if we multiply by 6 this range, we'll get 6 times the solutions. So 6 times 2 is 12 solutions. In II, we restrict the range from 0 to 1980. So 1980, it's 5 complete revolutions of 360 degrees plus 180 degrees. So I will certainly have 5 times 2, and then in the next 180 degrees, we can see that we will have 1 solution, so plus 1. That gives me a total of 11 solutions. In 10, it's a curve with this equation. The curve touches the x-axis at P and crosses at Q. And we need to state the coordinates of P. Well, if I touch or cross the x-axis, then obviously y is 0. So setting f of x to be 0 means that x minus 4 times 2x plus 1 squared is 0. Notice that the squared here is corresponding to a double root. So it's a double root. So either x is 4 or 2x plus 1 is 0, which means that x is minus a half. And that's actually the point P that we were after. So P minus a half, comma 0. In B, we need to find the derivative f dash of x. So I will actually start off by expanding f of x. It's x minus 4, and the expansion of 2x plus 1 all squared is 4x squared plus 4x plus 1, which upon further expansion will give me 4x cubed plus 4x squared plus x minus 16x squared minus 16x minus 4, which leads to 4x cubed minus 12x squared minus 15x minus 4. So f dash of x, I simply get the power down, deducting 1 from the power, leading to 12x squared minus 24x minus 15. C, hence show that the equation of the tangent at x is 5 over 2 can't be expressed in the form y equals to k. So I will start by determining the gradient of the curve at x is 5 over 2. So I'm just gonna say f dash of 5 over 2 is 12 times 5 over 2 squared minus 24 times 5 over 2 minus 15, which turns out to be 0. This means that the tangent at this point will be a horizontal line. We know that horizontal lines are of the form y equals to a number. So f of 5 over 2 substituted into my equation gives me negative 54, and I conclude that the equation of the tangent should be y is equal to minus 54. So it was a cubic, it probably looks something like this, and we have found that the tangent is something like that, either here or here. It's a horizontal line. And then part D, the curve y is f of x plus a, where a is a constant, passes through the origin O, and we need to state the possible values of a. I will actually try to produce a sketch of f of x just to explain exactly on what's happening. So the original curve was a cubic. It was having a double cut at minus a half, and then we've got a cut through the x-axis at 4. So it's gonna be something like this. And I will just add the labels here. This is a 4, this is the minus a half, this is y is f of x. And we've got y is f of x plus a, which is a translation a units to the left. So if we translate a to the left and we want this curve to pass through the origin, there are actually two possibilities. It's either I have translated 4 units to the left, so a is 4, or I have actually moved a half to the right, which means that a is minus a half. So once more, I have either moved to the left 4 units, so a is 4, or I have moved a to the right, so minus a half to the right, so a is minus a half, which leads to a is 4 or a is minus a half.